This short lesson is going to examine another method for finding the least common multiple. And there are several reasons why we want to identify the least common multiple of a set of numbers, but probably the primary reason, especially for this course, is to be able to add and subtract fractions a little later on. Right? So that's why we're looking at these techniques for finding the least common multiple. So what we saw in the previous video is that one way to do it was to list them. So like if I pick two numbers here, say 7 and 11, and I start listing the multiples, I would then examine both lists and try to find the smallest number that they have in common. But looking at 7 and 11 right now, I don't see any. So I would have to keep going. And then even after adding these multiples, I still don't see a number they have in common. So this is by way of showing you that listing them might work for smaller numbers like 3 and 4, 6 and 8, might work well for that. But for larger numbers or possibly groups of 3 or more, listing them could be very tedious, and honestly it could take hours if not longer. So we need another way. So let's look at 6 and 8. Even though I just mentioned that 6 and 8 are pretty easy to find the answer, the lowest common multiple for. We saw it was 24 in the previous video. Just using some small numbers will help illustrate this method a little easier to begin with. So let's look in 6 and 8. Again, we know the answer is 24. That's their lowest common multiple. Well, the second method says, step 1, complete the prime factorization of the numbers. So remember, that's looking for the set of prime numbers that multiply to make 6, and then the unique set of prime numbers that multiply to make 8. So we'll start with 6, and here I have the first 8 prime numbers listed. And we're going to start with the lowest primes and see if any of them go into 6. So for instance, does 2 go into 6? Yes, it does. And how many times does it go in? 3 times. So now we would continue to break these down if they are not prime. But are 2 and 3 prime? Yes, they are. So the prime factorization is 2 times 3. That's the unique set of prime numbers that multiplies to make 6. Let's go to 8. Again, we can start with 2. Does 2 go into 8? Yes, it does. 4 times. Is 2 prime? Yep, well, we just said it was, so it's prime. So we are done here. What about 4? Is that prime? No. Because 2 can go into 4 in addition to 1 and the number 4 itself. So 2 goes in twice to 4, so the prime factorization of 8 is 2 times 2 times 2. Okay. So that's step 1. Complete the prime factorization. Step 2. Is to list all of the different factors. Okay. So, notice we have a total of 5 numbers. We have a 2, a 3, a 2, a 2, and a 2. But how many different numbers do we have? Well, the number of different numbers is just a 2 and a 3. So I'm going to write those off to the side. Now, step 3. Step 3 says ID or identify the greatest number of times a factor occurs in any one factorization. Not across all the numbers, but in any particular one. So in order to illustrate this, I'm going to draw a set of 4 lines separating the 6, and I'm going to separate it from the 8. So here's our 6, here's our 8. The greatest number of times a factor occurs in any one factorization. So the 2 occurs in the 6 just once, but the 2 occurs in the 8 3 times. So in any one factorization, the greatest occurrence of 2 is 3 times. Again, not all, how many times does the 2 occur in all of the numbers, the prime factorizations, but only in any one prime factorization. So now how many times does the 3 occur? Well, it only occurs once. Okay, so that is step 3. And step 4 is to multiply those numbers. So what we have is 2 times 2 times 2, and then times our 1, 3. So 2 times 2 is 4, 4 times 2 is 8, and then 8 times 3 is 24. So the lowest common multiple is 24. So you might be saying, well, that actually took longer than just listing them, and it did. As I said, for small numbers, especially just 2 small numbers, listing them is usually better. It depends on how small the numbers are, what you consider to be small, but like 3 and 4, 6 and 8, 2 and 3, listing them is going to be better, but I just wanted to use 6 and 8 since we'd already seen it in the previous video, and I wanted to start to highlight this method, this factor tree method. Okay? So now I'm going to choose some larger numbers. Show you another example. Let's look now at 15 and 21. Alright, so step 1 is complete the prime factorization of both numbers. So start with the first prime 2. Does it go into 15? Nope. What about 3? Does 3 divide evenly into 15? Yes, it does. So what is 3 times what gets us 15? That's 5. And are 3 and 5 prime? Yes, they are. So we are finished with our prime factorization of 15, and it is the product 3 times 5. Okay. Let's go to 21. Does 2 go into 21? Nope. What about 3? Yes, it does. How many times does 3 go into 21? 7. Are 3 and 7 prime? Yes, they are, so this is complete now. We cannot break down 3 and 7. So the prime factorization is 3 times 7. Okay, so that was step 1. Step 2. List all the different factors. Okay? Well, we have a 3, a 5, a 3, and a 7. We have a total of 4 numbers, but we only have 3 different numbers. The 3, the 5, and the 7. So that's step 2. Step 3 is ID the greatest number of times a factor occurs in any one factorization. So again, to highlight this, I'm going to separate both of these. So how many times does the 3 occur in any one factorization? Just once. So even though you see the 3 appear twice across both numbers, In any one factorization, it only occurs once. That's the greatest occurrence of a 3. What about 5? Well, here it only occurs once, and it doesn't even occur in the 21, so it is just once. And the 7 only occurs in the 21 and not the 15, so it also is just once. So now step 4, multiply them. 3 times 5 times 7. 3 times 5 is 15, and 15 times 7 is 105. So the lowest common multiple of 15 and 21 is 105. And so now you can start to see, listing even these, now you're getting into the hundreds, would have started to take even longer. Okay? So this concludes this video, but I will now show one more example if you'd like to see that. We're going to look at 14 and 25. Step 1, complete the prime factorization of the numbers. So we'll start over here with 14. Start with our lowest prime. Does 2 go into it? Yes, it does. 2 times what gets us 14? 7. Okay. Can we break down 2 or 7 anymore? Nope. So we are finished. What about 25? Can 2 or 3 go into 25? 2 cannot. 3 cannot. So our next one is 5. And 5 times 5 is what takes us to 25. Step 2. List all the different factors. Well, we have 4 numbers, but again, we only have 3 different factors. 2, 7, and 5. So the greatest occurrence now, step 3, the greatest occurrence of a factor in any one factorization. The greatest occurrence of 2 is just once. The greatest occurrence of 7 is just once. And the greatest occurrence of 5 is twice. So even if there had been one 5 over here in this number, the greatest occurrence of 5 would have still been 2 because we're looking only at any one factorization. Okay? And now step 4, multiply them. 2 times 7 times 5 times 5. So what we have here is 7 times 5 in the middle is 35. 35 times 2 is 70. And then 70 times 5 is 350. So the lowest common multiple of 14 and 25 is 350, and this provides further evidence that listing this would have taken quite some time. So now that concludes this short lesson.